Have you ever wondered how it all began? The universe, our galaxy, the Earth, and everything we know? Well, strap in for a journey back in time, way back to about 13.8 billion years ago. Our story starts with the Big Bang Theory, the leading explanation about how the universe began. Picture this, everything that we now see, the galaxies, the stars, the planets, all matter, all energy, everything was once compressed into a singularity. This was an infinitely small, infinitely dense point. A point where our current understanding of physics simply breaks down. A point from where the universe as we know it sprang into existence. Now imagine from this singularity there was a cataclysmic event, a colossal explosion if you will, but this was not an explosion as we understand it. The Big Bang didn't happen in space, it was space itself that began to expand. And with this expansion, everything that would become the universe began to unfurl. In the moments following the Big Bang, the universe was extremely hot and dense. As it expanded, it also cooled. After a few minutes, it cooled down enough for protons and neutrons to come together and form the first atoms. These atoms were primarily hydrogen and helium, the simplest and lightest elements. These atoms didn't stay lonely for long. Drawn together by gravity, they began to form clouds of gas. And within these clouds, stars were born. Stars, with their immense gravity and heat, served as cosmic factories, producing heavier elements through nuclear fusion. As these stars lived and died, they scattered these heavier elements across the cosmos. And from these stardust, galaxies formed, each a dazzling collection of billions of stars. And that's the story of our universe, from its fiery, dense beginning to the cool, vast cosmos we see today. But remember, this is just the beginning of our cosmic journey. There's so much more to discover as we delve deeper into the mysteries of the universe. So that's how it all began, from a single, infinitely small point to a vast, ever-expanding universe. From the ashes of the Big Bang, galaxies and stars started to take shape. Picture a cosmic dance where gravity is the maestro, conducting a symphony of matter and dust to spin, whirl, and eventually cluster together. These clusters over a span of millions of years became the galaxies we know today, each galaxy a sprawling metropolis of stars. But what about the stars themselves? They are the result of yet another gravity-led performance. Within these galaxies, clouds of gas and dust were pulled together by gravity, growing denser over time. As they condensed, their core temperatures rose, igniting the process of nuclear fusion. This is the heart of a star, where hydrogen atoms are squeezed under immense pressure and heat, fusing together to create helium and releasing a tremendous amount of energy. Stars, the building blocks of galaxies, are nothing but a magnificent display of cosmic energy and gravity. Among the billions of galaxies out there, there's one particularly special to us, the Milky Way. Why? Because it's home. Our story begins about 4.6 billion years ago, in a quiet corner of the Milky Way. Picture a giant swirling cloud of gas and dust, known as a nebula. Driven by the force of gravity, this nebula began to collapse in on itself. As it did, it spun faster and faster, eventually flattening into a spinning disk. At the center of this disk, where the pressure and temperature were the highest, our sun was born. But what about the rest of the disk? Well, the outer regions weren't wasted. The leftover gas and dust began to stick together, forming clumps. These clumps collided and merged, growing larger and larger over time. This process, known as accretion, gave birth to the planets. Closer to the sun, the heat was too intense for volatile compounds like water and methane to survive. And so the inner planets, including Earth, became rocky worlds. Now, Earth's early years were nothing short of chaotic. Bombarded by asteroids and comets, the planet was a hot, molten mess. But over hundreds of millions of years, the surface cooled and solidified. Volcanic activity released gases trapped within the planet, creating an atmosphere. Water vapor in this atmosphere condensed and fell as rain, filling the basins to form the oceans. And here's where things get really interesting. In this water, under the right conditions, simple molecules began to combine and react, eventually forming the first living organisms. Over billions of years, these tiny microbes evolved, diversified, and gave rise to all life as we know it today. That's right, we owe our existence to a cosmic dance of dust and gas, a dance that transformed a nebulous cloud into a vibrant, life-sustaining planet. And just like that, our solar system was born, with Earth a tiny speck in the vast cosmos, destined to harbor life. Now let's zoom out a bit. What does the present universe look like, and what does the future hold? We stand at the precipice of a vast cosmic ocean, teeming with mysteries we are only beginning to unravel. This present universe, as we understand it, is a colossal tapestry of energy and matter, woven together by the threads of space and time. Let's consider dark matter for a moment. This mysterious substance, which does not interact with light, is believed to make up about 85% of the universe's matter. It's like the universe's silent partner, subtly influencing the dance of galaxies without ever stepping into the spotlight. Then there's dark energy, the phantom force accelerating the expansion of the universe. It's a cosmic enigma, making up about 70% of the total energy in the universe. Despite its ubiquity, we're still striving to understand what it is and how it works. Speaking of vastness, did you know that our universe is home to billions of galaxies, each one a bustling metropolis of stars, planets, and possibly life? The Milky Way, our cosmic neighborhood, is but one among countless others, a humbling thought that underscores the immensity of our universe. As for life beyond Earth, the odds are increasingly in favor. With the discovery of exoplanets in the habitable zones of their stars, the stage is set for the existence of alien life. The question is no longer if, but when we'll find it. But what of the future? Theories abound, from the Big Freeze, where the universe expands indefinitely, cooling and diluting until stars burn out and galaxies drift apart, to the heat death, where all energy is evenly distributed and no work can be done, leading to a state of cosmic stagnation. Yet these are but theories, and the universe has a knack for defying expectations. As we continue to explore the cosmos, who knows what fascinating discoveries await us?